So remember I talked about the steps in hypothesis testing. So now I'll be solving the first example. Example 1 says, a random sample of size 25 is selected from a population of mean and non-variance 100. Gives a sample mean equals to 52. Test the hypothesis when the population mean is equals to 49 for your null hypothesis and against the alternative hypothesis when your population mean is less than 49 at 5% level of significance. So now remember I said from the beginning that the first step is that you state your null and alternative hypothesis. Now that has already been given in the question. Remember from there we can see that h subscript 0 and your population mean equals to 49. Then your alternative mean, which is given at h subscript 1 with your population mean greater than 49. Now, this is your step 1. You first of all state the null hypothesis and the alternative hypothesis. Now, the step 2 is that you state your level of significance. And from the question, your level of significance is 5%. And remember I told you that in hypothesis testing, it is not written as 5%. Instead, it is written as what? As what? 0.05. So your step 2 is that you state your level of significance. And remember, it is represented by alpha. So that will be alpha equals to 0.05. Next is your step 3. Now, step 3 is you state the nature of sampling distribution, whether it is a z-test or a t-test. That's your test statistics, whether it's a z-test or t-test. Now, remember from the beginning, I told you that when you are dealing with z-test, your population variance is known. But when you are dealing with t-test, when you are going to use t-test is when your population variance is not known. And from the question, your population variance is known. So that's why we're going to use a z-test for this. So step 3, that will be z-test. And remember what I told you from the beginning. The formula for z-test is equals to what? That is your sample mean minus your population mean divided by your standard deviation over square root over n. Now from the question, our sample mean is given as 52. While our population mean is given as 49. That's why this 49 here. This remember from the beginning, okay? So 49. Then divide it by your standard deviation. And from the question, we're giving our population variance to be 100. So in order for you to get your standard deviation, remember that standard deviation is equal to your square root of variance. Now our variance is given as what? As 100. So we do square root of our variance, which is 100, to give us our standard deviation. So that will be square root of 100 divided by n. Square root of 100 to give us 10 divided by a square root of n. And from the question, our n is given as 25 because they said a random sample of size 25. So when you do 52 minus 49, you get 3. And square root of 100 is equal to 10. So 10 divided by the square root of 25, you get 2 as your answer. Then 3 divided by 2 is equal to what? That will give you 1.5. So now remember what I told you about the fourth step. The first step is that you state the significance of the test. And from the question, we can see that for the alternative hypothesis, there was direction, right? And it was showing that it is less than 49. So that means there is direction, meaning that it is a one-tail test. Then step 5, you find your critical value. Now remember from the beginning, I said that when dealing with critical values, it can either be seen in a situation whereby you are giving your z-test or a situation whereby you are giving the t-test. And also if it is in a situation whereby you are giving the z-test, you subtract it from a constant value, which is 0.5 to get your answer. Then after you get your answer, you then check it on the table. Then you get a number horizontal and a number vertically. Then you add them together to get your answer. So now let's use this to solve this particular one. So in order to get our critical value, we're going to do 0.5, which is that constant value. Then you subtract it from, you subtract your level of significance, which is 0.05 from 0.5. 0.5 minus 0.05, you get 0.45. Now, after you get this as your answer, you check. This is not your main answer. This is just a process to take in order to get your critical value. So how do we get our critical? The other process that you take is that you check your table. That is your Z table for 0.45 on the horizontal and vertical end of the table. When we do that, we see that we get two values, which are 0.05 and 1.6. Now, all you just have to do is add these two figures together. When you add them together, you get your answer as 1.65. So now, your critical value is equal to, I'll represent our critical value by CV, but in this lecture. So that means your critical value is equal to 1.65. Now, the next step, which is your step 6, is that you compare the absolute value of the test statistics. I remember I told you that your test statistics has to do with your Z test or T test. So you compare the absolute value of your test statistics and the critical value obtained from the table. Now, your calculated value is equal to 1.5. Why? From what we saw, and our critical value is equal to 1.65. How did I get 1.65? That's this critical value. Then for calculated value, how did I get the calculated value? That is from our test statistics. Remember I told you from the beginning that test statistics can also be known as calculated value. So don't get yourself confused. So after you do that, you get your calculated value as 1.5 and critical value as 1.65. Then the last step is that you take your decision. Now, how do we take this decision? Remember from the beginning, I told you that when your critical value is greater than your calculated value, you accept the null hypothesis. But if your critical value is less than your calculated value, you reject the null hypothesis. So in this situation, we can see that our critical value, which is 1.65, is greater than our calculated value, which is 1.5, meaning that the critical value is greater than calculated value, and meaning that we're going to accept the null hypothesis. So we'll be solving another question on hypothesis testing, and the question states: a sugar refiner packs sugar into bags weighing an average of 1 kg. The setting of the machine tends to drift, that is, the average weight of bags filled by the machine sometimes increases or decreases. If the mean weight of bags increases, is giving away some pipe sugars. If the mean weight decreases, he finds himself in trouble with weigh and measures inspector. He wishes to detect shifts in the mean weight of bags of sugars quickly as possible and reset the machine. To do this, he periodically selects a sample of 100 bags, weigh them and calculate sample mean and get 1.03 kg. If the variance of the weight of sugar is known to be 0.01 kg, use test hypothesis to assist him with appropriate decision to take. Test at 5% level of significance. So from our question, we'll be able to identify that the null hypothesis is equal to 1, because they said a sugar refiner packs sugar into bags weighing an average of 1 kg. So it is going to be written as your null hypothesis, your population mean equals to 1. So the second one is that you state your alternative hypothesis. And from the question, they didn't give us which direction. They said it increases or decreases, meaning that it is non-directional. So it will be not equals to 1. Now, for your step 2, you state your level of significance. And your level of significance denoted by alpha, that will be equal to 0.05. Step 3, you state the nature of sampling distribution. And from the question, our variance is given, so we use the z-test. Remember I told you, if your variance is given, you use the z-test. If variance is not given, you use the t-test. So in this situation, we're using the z-test. And remember I told you that the formula for z-test is equals to your sample mean minus your population mean divided by your standard deviation divided by square root of n. And from the question, our sample mean is equals to 1.03. Our population mean is equals to 1. That is from here. And our standard deviation was not given, but our variance was given. I remember the formula for standard deviation, which is equals to, for standard deviation, which is equals to your square root of variance. And from this question, since our variance is given as 0.01, we're going to square it, and you get your answer as 0.1. So your answer for standard deviation is 0.1. And our n is given as 100. Now you impute this into the formula. So that will be your sample mean, which is 1.03, minus your population mean, which is 1, minus your standard deviation, which is 0.1, divided by your n, which is 100. Now when you impute this in your calculator, you are going to get your answer as 0.03. You're going to get the 0.03 divided by 0.01, and you get your answer as 3. Well, this is not the last step. Step 4, remember I said you state the significance of the test. And in this situation, we're given from the null hypothesis. I mean, from the alternative hypothesis that it is not equals to, meaning that it is non-directional. And remember I told you that for it to be a two-state test, it has to be non-directional. For it to be a one-state test, it has to be directional, meaning it's either greater than or less than. But for two-state test, it is not equals to. So automatically, this is a two-state test. Next, which is your step 5, you are going to find your critical value. And for you to find your critical value, you go through two processes, which are, first of all, you subtract your level of significance from the constant value, which is 0.5. But in this situation, you don't subtract the level of significance from your 0.5. What you do is that you get your new level of significance, which is 0.05. That's the level of significance divided by 2. Remember I told you that for a two-state test, the normal distribution graph is like this, and meaning left hand side, right hand side, left hand side, and your alpha will be divided by 2. That's why what we're going to do is 0.5 minus our level of significance divided by 2. And in the question, we're giving our level of significance as 0.05 divided by 2. So you divide the alpha by, the level of significance, which is your alpha, by 2. And you get your answer as 0.475. Next, what you are going to do, that which is the final process, is that you are going to check your z table for the number you will get vertically and horizontally. And when you check your z table, you are going to get 1.9 and you are going to get 0.06. When you add them together, you get 1.96. So that is our critical value. So our critical value equals to 1.96. Now the final step, which is step 6, is that you take your decision. And in order for you to take your decision, you have to compare two values, which values, which are the values from the calculated value and value from the critical value. Now our calculated value, we got 3, while for our critical value we got 1.96. And remember, now we take our decision. From this we can see that the critical value is less than your calculated value, meaning that we are going to reject the null hypothesis. Why? Because the critical value is less than the calculated value. But if the critical value was greater than the calculated value, we would have accepted the null hypothesis. But since it is less than the calculated value, we reject null hypothesis. So in the previous calculation questions I've solved for hypothesis testing, those questions were showing that the population variance was known. But in this question that I'll be solving now, it is a situation whereby the population variance is not known. So now, if the population variance is not known, please take note that you are going to use the t-test for your test statistics. So now we'll be solving the first example. A random sample of 4 observations taken from a population whose distribution is normal with mean and unknown variance gives the following observations: 80, 40, 20, 60. Test the hypothesis when the null hypothesis for your population mean is equal to 70 against the alternative hypothesis of when your population mean is less than 70 at 5% level of significance. Now, from our question, we can see that we're given a sample of 4 observations. So from our question, we can see that the null hypothesis and the alternative hypothesis have been written down for us already. So we don't need to interpret that. So step 1, we just write them down. Your null hypothesis will be equal to 70 and your alternative hypothesis will be 70, less than 70. Now, step 2, remember what I told you. You are going to state the level of significance. And from the question, we're giving our level of significance as 5%. So automatically that's 0.05. And remember, it's represented by alpha sign. So 0.05. In this situation, we're going to choose a particular test statistics, whether it is z-test we're going to use or t-test we're going to use. And now our population is, our variance is unknown, meaning that we're going to use the t-test. Now remember I told you for t-test, it will be your population, your sample mean, to be your sample mean minus your population mean divided by standard deviation over square root of n. Now, the difference between this t-test and z-test is this standard deviation. For the z-test, it is not just called standard deviation, it is population standard deviation. While for the t-test, it is sample standard deviation. From the question, we're giving our sample mean. From the question, let's check if we're giving our sample mean. We're not giving our sample mean. So in order to generate our sample mean, what we're going to do is sample mean equals to summation x divided by n. Please take notes. And from the question, we're given various observations, which are x. We're given 80, 40, 20, and 60. We add all of them together. 80 plus 40 plus 20 plus 60. Then divide it by their total number. That's 1, 2, 3, 4. That's 4. Then when you divide them, when you add them together and divide it together, you get 50 as your answer. We're given our population mean to be 70. But in order for you to find your standard deviation, what you are going to do is, first of all, find your variance. Then you square your variance to get your standard deviation in this situation. So now, in order to get your standard deviation, you get your variance. And variance, the formula for variance is summation x minus sample mean square divided by n minus 1. So we solve for that. So that will be 80 minus 50 square plus 40 minus 50 square plus 20 minus 50 square plus 60 minus 50 square. Then you divide it by your degree of freedom. Please take note. N minus 1 is your degree of freedom. And we're giving our n from the question to be 4. So that will be 4 minus 1. Now when we solve for that, When you impute that in your calculator, you get your answer as 666.7. And when you impute this in your calculator, you get 25.82. Now you don't stop there. Now we impute all this into our formula. So remember, t-test equals to your sample mean minus your population mean divided by x, that's your standard deviation over n. And in the question, when we solved it, we got our standard deviation as what? As 50. So that will be 50 minus your population mean, which is 70, divided by your standard deviation. And we got our standard deviation as what? We got it as 25.82. So we write it there, 25.82 divided by your square root of n, and n is known as, from the question, we're giving our n to be 4. So when you do 50 minus 70 divided by 25.82 divided by square root of 4, which is 2, you get your answer to be 1, that's minus 1.55. When you get this, the next thing is to get your absolute value for your test statistics, which is your t-test. Now for your absolute value, it means when it is in a negative format, to put it in the absolute value to be in a positive format. So absolute value of tx, which is your test statistics of your t-test, is equals to 1.55. Now what's the difference? The difference is that here is positive, here it was changed from negative to positive. Then next, which is your step 4, you state whether it is a one-tailed test or two-tailed test. And from our question, we're given the sign less than. That's from here. Less than. Meaning that it gave us a direction. It is directional, meaning that it is a one-tailed test. Remember I said from the beginning, for one-tailed test, you have greater than or less than, meaning that it is directional. So I already identified that it is a one-tailed test. Next, which is your step 5, you get your critical value. In this situation, you get your degree of freedom and you get your level of significance. Then after you get that, you then look for it on your T table. To get our critical value, we find our degree of freedom. And remember, formula for degree of freedom is equal to n minus 1. And from the question, we had our n to be what? 4. So that will be 4 minus 1. So 4 minus 1, that will give you what? 3. You then get your level of significance. You state it, level of significance, which is equal to 0.05. Now, on your T table, not Z table this time around, on your T table, you look for 0.05 under 3. And you get your answer as 2.353. That is how we get the critical value in a situation whereby it is t-test we're dealing with. So now, the next step, which is our last step, is step 6. That is, we're going to make our decision on whether to accept or reject the null hypothesis. Now, in this situation, our critical value is given to be 2.353. And we got our calculated value, which is our test statistics. That's our t-test. We got our answer to be what? 1.55. So now, in this situation now, remember I told you when your critical value is greater than your calculated value, you what? Accept it. And in this situation, our critical value is greater than calculated value. So what do? We accept the null hypothesis